Every person alive on Earth today descended from ancestors with dark skin. Every single one. No matter what skin tone you have right now, the people at the root of your family tree, the earliest anatomically modern humans, were dark-skinned. This is not a social statement. It is a biological fact as well established as any in human evolutionary science. And understanding why that starting point was dark and why it changed for some populations and not others turns out to be one of the most elegant stories in all of evolutionary biology. A story about sunlight, about a vitamin, about two completely independent genetic solutions to the same survival problem, and a timing that will almost certainly surprise you. Start with the sun, because the skin is not a passive covering. It is an organ, the largest organ in the human body, and it has always had an active and complicated relationship with ultraviolet radiation. Ultraviolet light from the sun does two things to human biology that are completely contradictory. On one hand, it damages DNA, accelerates cancer risk, and most critically, it degrades folate, a B vitamin that is absolutely essential for the healthy development of a fetus, particularly in the first weeks of pregnancy before many women even know they are pregnant. Folate depletion caused by UV exposure has been directly linked to severe birth defects and developmental problems in the infant. On the other hand, ultraviolet light also triggers the synthesis of vitamin D in the skin, a compound that the human body cannot get in sufficient quantities from food alone, and that is essential for bone development, immune function, and the absorption of calcium. Without enough vitamin D, bones weaken. The immune system falters. Children develop rickets. Adults face significantly increased risk of infection and disease. Dark skin contains high concentrations of melanin, the pigment that gives skin its color. Melanin is an extraordinarily effective natural filter for ultraviolet radiation. It absorbs and disperses UV light before it can penetrate deep enough to damage DNA or degrade folate. In the environment where humans evolved, equatorial Africa, where ultraviolet radiation is intense and consistent year-round, dark skin was not an aesthetic feature. It was a survival mechanism. It protected folate during pregnancy. It reduced cancer risk. It allowed humans to function safely under one of the most radiation-intense environments on the planet. Then, humans left Africa. As populations began migrating northward out of Africa, starting around 60 to 70,000 years ago, they moved into environments where the relationship between sunlight and survival looked completely different. At higher latitudes in northern Europe, in Central Asia, the sun sits lower in the sky. The atmosphere filters out a larger proportion of UV radiation before it reaches the ground. The winter months involve months of extremely low UV availability. For a person with dark skin adapted to equatorial Africa, living in northern Europe meant that the very melanin that had protected their ancestors was now blocking the limited ultraviolet light they needed to synthesize vitamin D. The biological protection had become a biological liability. In these northern environments, lighter skin that allowed more ultraviolet light to penetrate and trigger vitamin D synthesis became a survival advantage. Women with slightly lighter skin could synthesize more vitamin D during the limited northern sunlight, which meant healthier pregnancies and healthier infants. Men with lighter skin had stronger immune systems and stronger bones. Over thousands of generations, in populations living far from the equator, natural selection consistently favored the genetic variants that reduced melanin production. Not because darker skin was in any way inferior, but because the ultraviolet environment had changed and the optimal balance point between UV protection and vitamin D synthesis had shifted dramatically. This is where the genetics become genuinely remarkable. When scientists sequenced the genomes of European and East Asian populations looking for the mutations responsible for lighter skin, they expected to find the same changes. They did not. The genetic variants that produce lighter skin in people of European descent are almost entirely different from the genetic variants that produce lighter skin in people of East Asian descent. Different genes, different mutations, different molecular pathways arriving at the same observable outcome. This is called convergent evolution, when natural selection independently arrives at similar solutions to the same problem in separate populations. It is one of the strongest possible signals that a trait is being actively selected for rather than appearing by chance. Lighter skin did not spread through northern populations by accident. It was selected, repeatedly, independently, because survival required it. The timing of this selection in European populations is one of the most surprising findings in recent paleogenomics. Ancient DNA recovered from early European hunter-gatherer skeletons dating to between 10,000 and 8,000 years ago consistently shows the genetic signature of darker skin. These were people who had been living in Europe for tens of thousands of years, and they still carried dark skin genetics. The gene variant most closely associated with light skin in modern Europeans, a mutation in a gene called SLC24A5, appears to have swept rapidly through European populations only around 5,000 to 8,000 years ago, coinciding with the spread of agriculture. Researchers believe the shift toward agricultural diets, which were lower in the vitamin D-rich fish and animal products that hunter-gatherers ate extensively, increased the selection pressure for skin that could synthesize more vitamin D from sunlight. The diet changed. The selection pressure intensified. The skin lightened. The entire story is a single biological equation. How much UV radiation is in this environment? How much folate protection does the body need? How much vitamin D can the body produce? The skin is the organ that has been solving that equation continuously for hundreds of thousands of years. The answer looks different at the equator than it does in northern Sweden, and natural selection found that answer independently on multiple continents through multiple genetic pathways. The diversity of human skin color is not an accident of history. It is the record of every latitude, every migration, and every generation of the sun-driven calculation that every human body on Earth has been running since we first walked out of Africa into a world of very different skies.